Hi. So the idea is that I'm going to go over the Cooper, Howard, and Heward Applied Behavior Analysis PowerPoint's book. It was not created by me, but I'm going to go ahead and go over them, try to give my little sense, my little 2 cents, and provide you another guide so that you can go ahead and study applied behavior analysis, whether it is for an exam or whether it is for anything else. If you just want to learn about applied behavior analysis, which is great. Okay, let's just go ahead and get started right away. So, chapter 1 is about the definition and characteristics of applied behavior analysis, right? And I learned how to switch slides here. I might be able to tell you the next slide talks about the basic characteristics of the science. So, what is science? It's a systematic approach for seeking and organizing knowledge about the natural world. So yeah, it's about uncovering the variables about our world. Natural world is the world around us, not outside in a laboratory. It's the natural world as it is right now. We're trying to uncover and seek and organize the knowledge about it. And the purpose of the science, as I was mentioning, is to achieve a thorough understanding of the phenomena under study. Now, in ABA, as a science, we are trying to uncover the phenomena of socially important behaviors, right? We know that there are socially important behaviors that people engage in, and we're trying to see and understand how does this phenomena come to be, right? So we seek to discover the real truth, not those held by certain groups or organizations, but really the truth about organizing, about the knowledge about the natural world, and in ABA, socially important behaviors, right? Okay, moving on. The three different type of investigations provide different levels of understanding. So the three levels of understanding are description, prediction, and control. Now, each level contributes to the overall knowledge base in a given field. Description is about collection of facts, about observed events that can be quantified, classified, and examined for possible relations with other known facts. Often suggests hypotheses or questions for additional research. So here the important thing is that we're collecting facts, we're collecting evidence about the events that we observe so that then later we can quantify them, we can classify them, and then be examined, right? So in ABA, for example, we do look at a behavior and we try to define this behavior so that we can quantify it. So for example, if we're interested in tapping the computer, we're going to define it, and then we're going to be able to define it in a way that we can take count of how many times the computer is tapped, then classify it as tapping the computer or tapping something else, and then examine it. What are the variables, under what conditions this phenomena in the natural environment occurs? That is all about description, right? The second characteristic is prediction. And prediction talks about the relative probability that when one event occurs, another event will occur or will not occur. Um, Based on repeated observations, revealing relationships between various events, demonstrates correlation between events. No causal relationship can be interpreted and enables preparation. So there's a couple of things here, right? So prediction, we have the description already of tapping on the computer, right? Now we're looking at what are the events that occur with that before, after, and so we're looking at the probability of how this event occurs in time, what are the events that precede and follow it, And are these events preceding following reliably, right? And so we're looking at the percentage there. That could be an example for this. Um, so we're looking at it, we're repeating the observations, right? To find if there's a relationship between the events that we're looking at. And demonstrate, so as we look at it, we can demonstrate that there's a correlation. So for example, I tap whenever I finish reading all of the words, and then I tap the computer, and perhaps the tap is to press the next button for the next slide. So there is a correlation between those events, right? But sometimes I also tap just because, and then it might be a correlation of something else, which could be because I just wanted to show an example. But before I talked about what I was going to do, I show the example. There's a correlation between those events. I talk, I'm going to tap about it, boom, I tap. Sometimes it doesn't happen. But the thing is, this is prediction. We're trying to uncover what are the relationship between the things that we're looking at and we're trying to study, right? Control. So this is the highest level of scientific understanding. This is how functional relations can be derived, right? And this is where functional relationships come into play in ABA. And we're trying to find this level of understanding in order to change the events, in order to manipulate the environment so that we can get the best socially um, significant behavior, right? So, um, so we can get the best socially significant behavior. All right, so control, the highest level of scientific understanding. This is how functional relations can be derived once we have established control over an event, right? So here we're trying to look at if there's a specific change in one event, dependent variable, and we're going to talk about dependent variable and how it relates. So a specific change in one event can reliably be produced by specific manipulations of another event. And the change in the dependent variable, which is the event that we're looking at, that we're interested, was unlikely to be a result of extraneous factors, confounding variables. So here for control, you just do this here really quickly. All right, so I'm going to use a whiteboard here for an example. If I can find the pen. Okay, great. So instead of the tapping of the pen, now we're looking at eating ice cream, right? So we're trying to understand this amazing phenomenon of me eating ice cream. Why? Why should I eat this delicious, creamy, yummy thing? Anyway, first, we're trying to describe it, right? We describe it, then we see what are the variables that come to it. And very important here for the level of control, this is the dependent variable. This is the thing that we're interested in, right? So what it says here is specific change in one event, the specific change in the dependent variable can be reliably produced by specific manipulations of another event. And the change in the dependent variable was unlikely to be the result of other extraneous factors. So the variables that I control me eating ice cream, let's say that I only eat ice cream whenever the ice cream truck passes by, right? So there's an ice cream truck. And I hear the song, of the ice cream truck and I just go running and always get ice cream. Right. So now we uncovered that every time the ice cream truck comes, I eat ice cream. Right. And then let's see. So if we change this event, for example, if instead of one time per day, we have the ice cream truck come 2 times per day, that is going to produce a change because now I'm not going to eat just one time, I'm going to eat 2 times. So the change that we're doing is the independent variable, right? And that is what we're interested in. The thing is, now we can reliably produce specific manipulations of another event, right? And then we're looking at the change. So now you're controlling my behavior by telling the ice cream truck to come a second time and to put it there. Obviously, this is a very simplified version of it, but hopefully it illustrates that this is the scientific level control, right? We're uncovering the variables and this is the only variable. There might be other variables as well, like for example, am I hungry? Have I just eaten? And all of these variables are going to be taken into account in a real, study. You're trying to uncover everything in order to see, the ice cream. And then there's other indirect contingencies as well that can be, for example, if I have a rule, and the rule is I only eat ice cream before 5 p.m. So even if the truck passes by a second time, if it's after 5 p.m., I won't do it. And this verbal behavior, this verbal rule has a control and is also another variable of the dependent variable of eating ice cream, which is the behavior here, right? So yeah, anyway, moving on. Ooh, why did I do that? Moving on. So, okay, so events can be really correlated and it's nearly impossible to factor out all other possible causes. So this is very, very important when you have the scientific level of control, which is what every scientist wants to achieve, to understand the phenomena, to create technology, to change behavior, to create technology to change the events in our natural environment. We have to make sure that there is not other causes, right, for it. So if we don't account for the other variables that are also influencing, we might not be able to establish a strong level of control. Right? Good. So the attitudes of science. So science and being a scientist, it's a lot about having attitudes, not an attitude about it, but just an attitude of how you see the world, right? So science, Skinner said that science is a set of attitudes. The definition of science lies within the behavior of the scientist, not the instruments or materials they use, only known as science due to an overriding idea of the scientific method, fundamental assumptions about the nature of events. So, like I said before, we talk about attitudes, but it's really just behavior, right? What are the behaviors that make a scientist? It's not what you know or how the instruments that you use, right? And the attitudes of science are determinism, empiricism, experimentation, replication, parsimony, and philosophical doubt. So determinism is an assumption upon which the science is predicted, right? The presumption that the universe is a lawful and orderly place in which all phenomenon occur as a result of other events, right? So there's always a cause and effect, right? So events do not just occur at will, right? We don't live in a vacuum. Events are related in systematic ways, right? So, like I said, there's a cause and effect. This is how you can learn determinism. It's a lawful and orderly place. There's a cause and effect between phenomena that are determined. So one thing is determined to happen because another thing happened. All right, next one. Empiricism. The practice of objective observation of phenomena of interest. What all scientific knowledge is built upon. It's objective. It's the key to gaining a better understanding of what is being studied. Right? So it's not enough to go in, look at a phenomena, and start writing conclusions about it. The practice of objective observation really is where you want to start. And this is, again, it's very related to the description um, where you are looking at how can you identify the variables in an objective way, making sure that you don't have preconceived notions that are affecting the way that you're viewing something. Experimentation. Basic strategy in most sciences, right? You experiment. So what does it mean to run an experiment? So they are controlled comparisons, some measure of the phenomena of interest, right? The dependent variables that we were talking about, under two or more different conditions in which only one factor at a time, independent variable, differs from one condition to another. And there's two important stuff here that we need to look at. Controlled comparisons, right? So like I said before, you want to be objective, you want to be thorough when you compare the measures of the phenomena of interest, and then you measure it under different conditions, and you make sure that you're only changing one factor at a time. So for example, for the ice cream, if you want to really know what is it that influences me eating ice cream, then you have to test it under different conditions. So perhaps one day you say to the ice cream truck guy, do not pass by. And you'll see if during that time, during that day, do I eat ice cream? And perhaps at, before 5 p.m., I noticed that the ice cream truck hasn't passed by. Then all of a sudden, you see that I go out and I get ice cream. And so you see that perhaps it's not only the ice cream truck, which is the factor here, right? And then you can also test it in a different, you do a different ice cream truck, with a different song, and you see what are the changes there, right? But you do it around, the same time before 5 p.m. and you're changing variables to see what are really the things that are, controlling the behavior of me eating ice cream. So perhaps you can give me food before to see if it's hunger as well. Perhaps you can deprive me of food to see if that increases the frequency, or even if I, instead of just asking for one piece of ice cream, I ask for two pieces of ice cream because I'm not eating it. So you're trying to, again, see what are the variables. You're trying to experiment. You're comparing the measures of the phenomena by changing the conditions. Then we have replication. And the replication is the repetition of the experiments to determine the reliability and the usefulness of the findings. So like I said before, you want to not only go in and look at the phenomena one time, not only go in and experiment one time, you want to replicate yourself. You want to repeat the observations. You want to repeat the experiments so that, you make sure that you're being thorough, right? So, and you see your method and you can see if there's mistakes. right? Parsimony is the idea that simple, logical explanations must be ruled out experimentally or conceptually before more complex or abstract explanations are considered. So it helps scientists find fit findings within the field's existing knowledge base. So parsimony, basically, in other words, is that you want to rule out, the most simple explanation before finding very complex or abstract explanations. And one thing to think about this in the ice cream example, which probably I've been using the ice cream example a lot. We'll continue with that. Anyway, a scientist can come and say, well, I don't know what's really going on. I don't know yet what are the variables. And then another person can come and say, the thing is that the song actually comes from these people who have found a way to tap into the unconscious mind and submit a program that the person now cannot resist eating ice cream when they hear this sound, right? And so this is a very complex explanation, right? Because now you have some programming involved, and the song is going into the brain, and there is some unconscious part of your brain that is being something is being activated there, and there's so many questions, right? Um, and then the scientist can after doing experiments, and he just realizes perhaps that it's much more simple. And instead of believing this other story, which could make sense, could make total sense, because if you look at it, the song plays, person gets ice cream. Song plays, person gets ice cream. So you see, oh, okay, well, the song might be, and then you find some logical explanation here. I mean, logical, um, and it makes sense. It falls into the story very well. There's a lot of things that you know that we can look at that way. Anyway, the thing is, what's I gonna say? Sorry. Anyway, the thing is that you want to rule out the most simple explanations. So first, you want to start with what are the basic. After you have run a couple of experiments, after you have run and try to uncover the variables, you want to see what are the basic explanations for this, experimentally. So if you take away the song and you just put, for example, a horn, and you see that the person still goes out after he hears the horn of the ice cream truck, or even just perhaps, the person can hear the sounds outside and hears the truck or sees the truck, and he still goes and buys the ice cream, then perhaps it's not the song which was the determining factor or the variable there. Um, Perhaps it's just simply the availability of the ice cream truck being there. So basically, what I'm trying to say is that you have to rule out more logical and simple explanations before considering more complex ones, right? And after you ruled out, keep going and keep going a little bit more complex, and then perhaps you can find the answer there. Not discrediting anything, you know? And that brings us to one of the most important ones. Philosophical doubt is the continuous questioning of truthfulness and validity of all scientific theory and knowledge. Involves the use of scientific evidence before implementing a new practice, and then constantly monitoring the effectiveness of the practice after its implementation. So philosophical doubt is like having healthy skepticism. You are always questioning the truthfulness and validity of all scientific theory and knowledge, even the stuff that you have the most evidence. The moment that we say we know, when we stop trying to uncover the variables with the new information that can be coming in, the new evidence, we are just limiting ourselves and limiting our science, limiting the technology that we can create. And so, this is why in ABA, you want to always constantly monitor the effectiveness of the practices that you're doing. You always want to go back to your graphs. You always want to go and see how can how can I make this better, right? Perhaps you learned about a procedure for implementing. So, for example, you want to increase MANs using functional communication training, right? And so you learn about a procedure in which you use to teach an alternative MAN in order to establish this behavior and reduce other behavior. And then you make a hypothesis about a function and you say that, oh, this behavior that we're trying to reduce and replace is, after my observations, after all the assessments that we did, we uncovered that the variable is social reinforcement in the form of mom's attention. And then you have this hypothesis, you create a program for it, and and then you see the data you're monitoring, and you see that there's not a change. You take baseline data, you implement, and then you see that there's not a change. And so, um, does it mean that you're not a good scientist, that you're a bad practitioner, or anything like that? No, it just means that you have to go back and try to see if there is any other tools that you can use in order to uncover what really is the variable there, and then also see how is the practice being implemented. You have to see, are you running the procedure correctly? Are you enlisting this? I'm losing my train of thought here. I don't know what's going on. Okay, so for example here, so philosophical doubt, I call this healthy skepticism, is the continuous, sorry, okay, so philosophical doubt is the continuous questioning of the truthfulness and validity of all scientific theory and knowledge. Give me just 1 second. All right, so philosophical doubt, the continuous questioning of the truthfulness and validity of all scientific theory and knowledge. Hmm. Involves the use of scientific evidence before implementing a new practice, then constantly monitoring the effectiveness of the practice after its implementation. So, philosophical doubt can be also thought about a healthy skepticism, right? And so you are questioning the truthfulness and validity of everything that you do, every scientific theory and knowledge that you're implementing. You always have to have some healthy skepticism. And that might look like um, tracking your data, making sure that what you're doing is going to be beneficial for your client and not just relying on the procedure, but tracking to see what are the effects of this procedure, right? How is the dependent variable that we're looking at going to change with this independent variable? And that's one of the things that I really love about ABA, that we don't have a, okay, this is a symptom, this is a diagnosis, or this is a symptom, this is how we treat it. It's not like that. We have, okay, this is what we're interested in, this is where we want to get there. These are things that we might that could benefit. Let's implement here this, let's take an element of here and see how it responds. Okay, it's not going the direction we want it to go. So let's change it, let's tweak it here until we can make it there. What I'm saying is that every person, every patient, every person who, um, every plan is individualized, and you can't rely on cookie cutter things. You have to always question. Um, you always have to question the validity of the things that you're doing by tracking the data, by evaluating your procedures, by monitoring all those stuff all the time. And in science, this is just question everything. In a broader scale, Newton came up with formulas to describe the movement of the planets around the sun, right? But then when they look at planets that are orbiting outside in other galaxies where, there are different movements, different scales and everything, they found that the laws of Newton, those formulas did not apply. So then Einstein came along, and he, with his general theory of relativity, he created new formulas, and they were able to account for not only the planets in this system but the planets in other systems and stuff like that. And the science is always evolving. Now we have quantum physics, which are explaining other stuff. And what I'm trying to say is that there was people who believed the earth was flat, at some point in time. And if we continue to just take, um, the stuff that we have created with the evidence that we were able to uncover at that moment, we are just not giving chance for, understanding the phenomena, to have better control with the phenomena, to create better technology, and to an ABA to be more effective, to help the people that we're serving. It's very, very important. Um, very, very important attitude to have. All right, definition of science. So, as we talked about before, science is more about attitudes, as far as like behaviors, right? But we want to define science, which not a lot of people have done. Science is a systematic approach to the understanding of natural phenomena, as evidenced by the description and control, that relies on determinism as a fundamental assumption, empiricism as its prime directive, experimentation as its basic strategy, replication as its necessary requirement for believability, parsimony as its conservative value, and philosophical doubt as its guiding conscience. Yeah, so it's basically putting everything together here. into a definition. Moving on. The development of applied behavior analysis. So behavior analysis is comprised of three major branches, right? Behaviorism, which is the philosophy of the science of behavior. Experimental analysis of behavior, EAB, is the basic research. Applied behavior analysis, the development of technology for improving behavior, and that can only be understood in the context of the philosophy, basic research, traditions, and findings, right? So if we see this in a tree, behaviorism is a philosophy of the science of behavior, right? So before the experimental analysis of behavior could be established, there was a philosophy that, hey, I think that we can look at behavior in a way that is determined, right? That there's cause and effect. So why don't we try to experiment with it and see, what we can uncover? Started doing basic research on it, like putting pigeons in an operant chamber where they pecked the button and food came out, and they saw, wow, if food comes out when the pigeon does this, this happens. When if food doesn't come out, this happens. If food comes every 2 times that the pigeon does it, this happens. If it comes in a set period of time after the pigeon does it, this happens. And so using, like I said, parsimony, changing one variable at a time, using basic research, they uncovered behavior, right? Where they're uncovering the variables that affect behavior. And then, obviously, like these experiments, when evolving into much more, and they fed each other more of the philosophy, they fed more of the research, and like that, it's an evolving process between both. Then they started developing the technology for improving behavior and the applied behavior analysis, right? And applied behavior analysis does research as well, but now the research is focused on socially significant behavior, and most of them are human beings. And we're uncovering complex human behavior, the variables there, and how can we use what we have learned to develop a technology to help them, right? Psychology in the early 1900s was dominated by the study of states of consciousness, images, and other mental processes. Watson was recognized as moving the field of psychology in a new direction. He argued that the subject matter for psychology should be the study of observable behavior, not states of mind or mental processes. Early form of behaviorism known as stimulus response psychology, or Watsonian behaviorism. He created the foundation for the study of behavior as a natural science. B.F. Skinner in 1938 B.F. Skinner, The Behavior of Organisms, 1938-1966. He formally began the experimental branch of behavior analysis. He summarized his laboratory research from 1930 to 1937, and he discussed 2 types of behavior, respondent and operant. Respondent is also known as Pavlovian conditioning, right? The dog, the salivation. A lot of people who go into psychology or have taken a psychology course, high school or college, might have heard of this Pavlov and his dog, and the salivation and the bell. That is what we know as respondent conditioning behavior. Respondent behavior, oh, here it is. Reflexive behavior. Ivan Pavlov was the one who brought this up. He said that responses are elicited, they are brought out by stimuli that immediately precede them. And the thing about eliciting and brought out is that these are reflexes, right? So we're talking about things that um, are generally not in our control, you know? So, for example, if somebody um, tries to put their finger inside of your eye, your first response is going to close your eyes, right? It's a reflex. So these are the behaviors that we're talking that he was looking at here, and he was looking at antecedent stimulus and response, and the responses that it elicits form a functional unit called a reflex, right? So we have the antecedent stimuli. In his case, was the sound of a bell, and the response that it elicited was salivation. And these two, stimulus, response, is this unit is called a reflex, right? And they are mostly, like I said, involuntary responses. They occur whenever eliciting stimulus is present, the SR model. Now, then we have operant behavior. Now, operant behavior is behavior that is shaped through the consequences that immediately follow it. The three-term contingency model was born, which now it is stimulus that comes before the behavior itself, the response, and then another stimulus. And the behaviors are influenced by the stimulus changes that have followed the behavior in the past. So now is the reflex, remember, was there's a stimulus, there's a response. Now there is a stimulus, there's a response, and there is a stimulus that follows. And what determines this operant behavior is the change that followed the behavior in the past. So what is the stimulus here that happens? So for example, in the case of let's put an example with the dog. So the reflex here for Pavlov was he rang a bell, the dog salivated. Let's say that when he rang the bell, okay, so let's say that when Pavlov was close by and he had food in his hand, the dog barked. If the dog got the food after he barked, then that he's operating in the environment and he is engaging in a behavior that he is getting now the food, right? So there's a change in the environment that he did by operating the behavior, and now he's getting the food. Let's say that, you know, he barks, he sees the food, he barks, he doesn't get it, and this is as well. If he doesn't get it, this might influence the behavior. And we're going to talk about that. This is all the processes of reinforcement. But what I'm trying to say here is that operant is behavior that operates in the environment, is, you know, we can argue that is not reflexive, that is not voluntary. Um, and we're looking at a three-term contingency that influences this type of behavior. Experimental analysis of behavior, EAB. So it's named as a new science by Skinner. It outlined specific methodology for its practice. The rate or frequency of response is the most common dependent variable. Repeated or continuous measurement is made of carefully defined response classes. Within subject, experimental comparisons are used instead of designs comparing the behavior experimental and control groups. So yeah, Skinner, you know, established the experimental analysis of behavior, and he outlined the methodology for the practice of it. And he now looked at the dependent variable is the rate or frequency of a response, right? How many times does the person, the pigeon, the organism engages in this behavior across time? when I'm changing all these independent variables here and there, right? And like we said before, it's very important to have repeated or continuous measurement of the carefully defined response classes, the carefully defined dependent variables, right? So we're definitely being as objective as possible. We're repeating and continuously measuring here using all the attitudes of science here, right? And now we're not looking at, in many studies that they do, correlational studies where they look at, if there was a statistical significance here. He's looking at one organism. The behavior of one organism is compared to itself, right? So that he looks at one behavior, one dependent variable, and how it's being changed. It's very powerful, right? Because, as you know, not everything affects everybody the same way. So, for example, if I conduct a study with, let's just say, me and my brother, there's a study. They're trying to see if they can teach us to learn Italian in 1 week. And they put us in the same classroom, same professor, same everything. But 1 week later, I guarantee that one of that we will have a different level of understanding of Italian at the end. It might be that he has a better understanding, or he can speak Italian better. He performed better on the test than I did, and it was the same independent variable, right? That was implemented. But there might be other differences within the person. But if now you put these two people, this is the important part, the difference between within subject and the experimental comparisons that they do when they put big control groups and statistical analysis, and now they take an average. Okay, now my brother did 100% on his exam, and I did only 80%. Um, and then they say, okay, well, the average of this was, what would it be, 90%? So they could say, like, our procedures were effective 90%. That is the average of the score that they get in the competency exam at the end. But they are not accounting now the individual differences between me and my brother, because he got 100 and I got 80, and that is perfect compared to it's good, you know. So that is why having one subject is very powerful, because you can see the individual changes, the individual application of this variable, right? Just let's move on here. There is a specific methodology for its practice. So these include the visual analysis of graph data is preferred over statistical inferences, like we were talking about. So now you see, what you can do is that you can put in a graph every time me and my brother take a test. We have a separate graph, and they look at, okay, the first time he took a test, it was 100. Second time he did 100 again. The next time he did 90. But across time. And then I had 80, then I had 60, and then I had 40. And now we're looking at, um, you know, specific trends here. Let's say if we, like, again, a statistical inference could be that we put all of this average, and let's say, like, okay, that across time, um, they averaged out in 50. So 50 was the percent that both of them averaged out on. But they're not accounting the differences, the big range of differences. So My brother got 100, 190, and then I got just lower grades. And there's so much variability there that is being just put all together and saying like the average amount was 50. And obviously, statistical inferences, are not just taking the average. There's so much more. But what I'm saying is, if you zoom in and you just see the individual data, you might get a better understanding, an individual understanding, right? And so this is preferred in experimental analysis of behavior. But the other data is not that it's not that it's a better understanding, or it's not that is not valid. It's just that what we're interested, or what they were interested in the experimental analysis of behavior, it was better viewed in that way. And then there is a description of functional relations is valued over formal theory testing. And that is, another thing most of social sciences, what they did, and I remember this from, my undergrad in psychology, was that they had a theory, right? So it can be something as simple as um, compliance compliance increases in social situations. So now we're going to group 10 people here who will put in a social situation, and we'll see if they comply more to a request than where they're not in a social situation. And so they see here 5 participants did comply in the social situation, the other 5 did not, and then in the other one, nobody complied in the social situation. They said because there were 5 participants, 50% did comply. They run it through, some statistical inference, and they say like, oh, there is 0.0 or something. I don't remember very much the measures that they use, but they say like, oh, there is some statistical significance, right? But then what happened with the people who did not comply in the social situation, and that is why, um, again, functional relations is valued when you're looking at one person and trying to understand and uncover what were the variables that influenced the people who did comply and the people who did not. And you start to understand from this is not just the social setting because they were all in the same setting. What are the other variables, right? That was uncovered. And remember the ice cream truck, perhaps the motivation, of eating ice cream was also one thing. The rule of eating ice cream after 5 p.m., all these things were variable that it can influence the behavior. And human behavior is very complex. So the more we can zoom in and uncover what's going on, the more we can have a thorough understanding. Skinner and colleagues conducted many laboratory experiments between 1930s and 1950s. They discovered and verified basic principles of operant behavior. The same principles continue to provide the empirical foundation for behavior analysis today. So more than almost 90 years ago, right? They discovered and verified the basic principles of operant behavior, and they continue to influence the practice today. That's why Skinner is one of the most prominent people, most important people in our field. Person. B.F. Skinner, the founder of experimental analysis of behavior. He wrote extensively. He wrote so much. And he was very influential in the guiding practice of the science of behavior and in proposing the application of the principles of behavior to new areas. Walden 2, a book in 1948, beautiful book that talks about how we can use the technology of behavior to create a society based on this technology, the improvement of human society, and using technology in a way that helps us live a better quality of life. Very, very beautiful and powerful book. Science and Human Behavior, 1953, and About Behaviorism in 1974. Philosophy of science became known as radical behaviorism, which we'll talk about right now. Radical behaviorism attempts to explain all behavior, including private behavior, such as thinking and feeling. Methodological behaviorism, philosophical position that considers behavioral events that cannot be publicly observed to be outside of the realm of the science. So this is very, very important here, to know the distinction between the two. Now, radical, the name radical, um, comes from being thorough and not from being like crazy or something like that. I feel like that might be a connotation sometimes that can happen there, but it is radical because it's thorough. He established that private behavior are subject to the same contingencies, the same variables that affect behavior that we can see, but now it's private behavior. It's behavior that is not accessible um, to other people. It's not observable, right? Unless you're using like really special instruments or perhaps not. Even with even with the those big magnets that look at the brain and they say they show a picture to a person. Sometimes the information that comes up is just like, oh, this area lit up, but they can't really hear what the person is thinking or see or feel what the person is feeling. Um, you know, so our technology is not there. And perhaps these behaviors are just going to be accessible to the person and they're going to remain as private behavior. We don't know. But radical behaviorism attempts to explain all behavior. Methodological, it's very different. They say if we can't observe it, it is outside of the realm of the science of behaviorism. Mentalism. Okay, so mentalism is an approach to understanding behavior that assumes that a mental or inner dimension exists that differs from a behavioral dimension, and that phenomena in this dimension either directly cause or at least mediate some forms of behavior, relies on hypothetical constructs and explanatory fictions, dominated Western intellectual thought and most psychology theories. Descartes, Freud, Piaget, so this is a way to try to explain behavior, right? And this assumes that a mental or inner dimension exists that is the one where the phenomena of this dimension directly cause or influence behavior. This relies on the premise of explanatory fiction, such as knowledge, a fictitious variable that often is simply another name for the observed behavior that contributes nothing to an understanding for the variables responsible for developing or maintaining the behavior. So this comes to a circular view of cause and effect. Okay, so I'm going to go ahead and try to explain this. Um, so let's say, again, let's go back to the example of the ice cream truck. Let's say that we uncover the variable, and the variable here is that influences the behavior of me eating the ice cream is the sound, right? Because I'm not looking, I'm just, at that time, I'm usually sitting at my desk working, and I hear the sound and I go out, right? But there's also, another variable that if I haven't eaten lunch that day, I might, if I had eat lunch very close to that, then I might skip the ice cream there. Anyway, you understand that there's a couple of variables, and you conclude that is the sound is the variable that came after. There is a motivation if I eat or not, and then there's the behavior. I go out and eat ice cream, and I get access to the ice cream, and that's how it happens. Now, Mentalism can be an understanding of it, can say, well, he eats ice cream because he wants to eat ice cream. Why do you say he wants to eat ice cream? Because he went to get the ice cream. Why did he went to get the ice cream? Because he wants to eat ice cream. And so it goes to a circular view of cause and effect. Now, this is a very simple explanation, but then there can also be another explanation. For example, if you now start to use the id, the ego, the superego, and you start saying like, oh, well, he wanted to eat the ice cream. He ended up eating the ice cream, even though his superego said that no, he cannot go and eat the ice cream, but the id was so powerful and it really wanted the ice cream. So it overcame the superego. It overcame, the cognitive dissonance that he had of having this ice cream. Um, and then he went to go ahead and get it. And we're talking about these hypothetical constructs. We're talking about things that are on our mind that we cannot observe, the ego, the superego, and we don't have an account for them. We don't. How can we observe the? How can we um, um, control these variables? From this understanding that relies on abstract um, or things that we cannot see or observe in an inner dimension, right? That is inside of the mind, the unconscious mind. It's a lot harder to understand, right? And sometimes this goes back to a circular view of cause and effect. Structuralism. So this is states that rejects all events that are not operationally defined by objective assessment, restricts activities to descriptions of behavior, make no scientific manipulations, and do not address causal questions. Methodological behaviorism rejects all events that are not operationally defined by objective assessment, to deny the existence of inner variables or consider them outside the realm of scientific account, acknowledge the existence of mental events but do not consider them in the analysis of behavior. They use scientific manipulations to search for functional relationships between events. Is a restrictive view since it ignores major areas of importance, right? Because private thoughts and feelings do influence behavior, and they are important, you know? So, for example, in the ice cream example, let's say that you uncover the variables, but that day I had listened to a podcast talking about how dairy was bad, and I was thinking that I wanted to change my habits. And even though I just listened to that same day, I was having this thinking. And when I heard the ice cream truck and I hadn't eaten and all the variables were there, I said to myself, I am not going to go eat ice cream. And I was thinking. And if a person was there, perhaps they did not see that I was thinking, but they will be able to see that I did not go ahead and get the ice cream. And if you are a methodological behaviorist, then you might not be able to understand or not understand, but if you deny the existence of the importance of me thinking, then perhaps you're going to miss out on uncovering what it is that affects my behavior, and you will have not a full account to that, right? So yeah, just stuff to think about. most people that I know are radical behaviorists though. And more research is uncovering the variables of thinking, the variables of how these private events influence behavior. So it's a very exciting time to look at how our field has developed. Anyway, Skinner did not object to cognitive psychology's concern with thoughts and feelings, events taking place inside the skin. They refer to these as private events, right? They are behavior to be analyzed with the same conceptual and experimental tools used to analyze publicly observable behavior. Radical behaviorism, Skinner's behaviorism, makes three assumptions about the nature of private events. These are the main assumptions and tenets, per se, of this. So private events, such as thoughts and feelings, are behavior. The behavior that takes place within the skin is distinguished from other public behavior only by its inaccessibility, right? And the private behavior has no special properties and is influenced by the same kinds of variables as publicly accessible behavior. So again, that's I think I mentioned this before. It is subject to the same variables that influence um, the behavior that we can see. It has some special properties, just that it is not accessible to everyone. It's mostly accessible to the person who is engaging in the thought and the feeling or any private event. Radical behaviorism, Skinner's behaviorism, includes and seeks to understand all behavior. And again, it is radical because it's far reaching and thoroughgoing. It is dramatic departure from the conceptual systems that were placed before. Fuller in 1949 conducted a study that to report the human application of operant behavior. And this was the first time that applied behavior analysis did a study. And basically, they had a participant, an 18-year-old boy with profound mental retardation. Remember that at that time, mental retardation was a diagnosis. They used that word, and now, it has a very negative connotation, and people use it to make fun of other people. And perhaps there's different words that we can use now, but the most important thing here is that the doctors, the physicians who were looking at this 18-year-old boy, they were saying he is not going to learn anything. They consider him a vegetative idiot. That's quote unquote. I read that. And so Fuller came by and he did this study, and he taught this boy to raise his arm by injecting a small amount of warm sugar milk solution into his mouth every time he moved his right arm. And he had a very limited period of time to do this. And the physicians all agreed that if he had more time, he could have taught this boy to do a lot more. But this was one of the most powerful demonstrations of how the philosophy, the basic research came together in order to create this change, right? He uncovered the variables of the behavior of raising his arm, and he used it to teach him to do that. It's very powerful. Then Aylon Michael in 1959, they named the paper the psychiatric nurse as a behavior engineer. They formed the basis for a branch of behavior analysis that would later be called applied behavior analysis, by teaching nurses to use the principles of behavior to improve the functioning of chronic psychotic or mentally retarded residents in a center. So these were ABA nurses who were going around implementing programs for to improve the functioning of the people who were there. This is awesome, awesome, awesome time. In the 1960s, the researchers began to apply principles of behavior in an effort to improve socially important behaviors. Techniques for measuring behavior and controlling and manipulating variables was sometimes unavailable or inappropriate. So, this is the early times, the 1960s. So obviously the techniques for measuring the behavior and all the techniques were not as refined as they are today, right? And also we have to look at that there was little funding available, you know, and there was not an outlet for publishing studies. So it was difficult to communicate findings. Even today, applied behavior analysis has a lot of outlets for publishing their studies, but there's not a lot of cross with other areas of science and research, and that's something that a lot of people have recognized that is very important. So yes, but the field is growing, and I'm sure that we're gonna get there because there's a lot of good change that is being done. Despite the limitations of the 1960s, many applications of behavior principles were made. The application of behavior principles to education is a major, major area of impact, provided the foundation for behavioral approaches to curriculum design, instructional methods, classroom management, and generalization and maintenance of learning. So imagine like how beautiful it is that knowing that behavior analysis provided a foundation for all these changes in education. And there's still a lot more that can be done and a lot more that has been done. 1960s and 1970s. Many new university programs were developed in applied behavior analysis, right? The teaching and research conducted in these programs made major contributions to the rapid growth of the field. By this time, like it's saying here, there was research being conducted in university programs, and the field was growing exponentially. Formal beginning of contemporary behavior analysis started in the 1968 when the Journal of Applied Behavior Analysis, JABA, began publication. And then some current dimensions of applied behavior analysis, a paper by Bear, Wolf, and Risley came out to outline the dimensions of applied behavior analysis. And these are, not yet. The Journal of Applied Behavior Analysis, JABA, was the first journal in the US to deal with applied behavior problems and gave researchers using methodology from the experimental analysis of behavior an outlet for publishing their findings. It's a flagship journal of ABA. So Beowulf and Risley, with their article, they were considered the founding fathers of ABA. They defined the criteria for judging adequacy of research and practice in ABA and outlined the scope of work for those in science. This is the most widely cited publication in ABA and remains the standard description of the discipline. So they recommended the following 7 defining dimensions for research or applied behavior change programs: applied, behavior, analytical, technological, conceptual, effective, generality. Applied investigates socially significant behaviors with immediate importance to the participants. Examples include behaviors such as social, language, academic, daily living, self-care, vocational, recreational, or leisure, right? The characteristic of behavioral means that it uses precise measurement of the actual behavior in need of improvement and documents that it was the participant's behavior that changed. The behavior in need of improvement, and it is the study of behavior, not about behavior. The behavior must be measurable. important to note whose behavior has changed, right? Um, analytical, analytic demonstrates experimental control over the occurrence and non-occurrence of behavior. A functional relation is demonstrated. Functional and replicable relationships, right? So again, applied behavior analysis, even have it has it in its word, we're trying to demonstrate with experimental control the utmost level of scientific understanding, the occurrence and the non-occurrence of behavior. So what are the variables when it does occur, when it doesn't occur, so that we have a thorough understanding and we have what we call a functional relation that we can demonstrate and, reliably reproduce in order to find a way to improve the quality of life of people, right? Technological. Technological means that the description of all the procedures in the study is sufficiently complete and detailed to enable others to replicate it. So this is what technology means. It's not science, any science. If you can't really explain it to your grandmother, and she cannot take, an understanding and how to use it and how to replicate it, then might not serve very well. Of course, there's things that are very, very, very complex, right? Like, even if Einstein came and he tried to explain to me um, how to apply the general theory of relativity in order to create, a an electronic device, I might not be able to understand it fully. But if he has a written description of the procedures, or he has a sufficiently complete and detailed procedure that he can perhaps write or explain and walk me through, then he has developed this technology, right? And so all the procedures are identified and described in detail and clarity so that we can replicate the technology. We can replicate what we do so that other people can do it and they can also take advantage of the principles of behavior to improve people's lives. Conceptually systematic. Behavior change interventions are derived from the basic principles of behavior to better enable research consumer to derive other similar procedure from the same principles, assist in integrating discipline into a system instead of a collection of tricks. So what we're saying here is that the behavior interventions that are used are derived from the principles of behavior, right? We're not trying to reinvent the wheel um, every time we go into a case. We understand that there are variables that influence the behavior of people, and we understand that what comes before or after a behavior influence the behavior itself, and based on this findings, these principles that were found in research, we develop procedures from it, right? And so it gives us a discipline, a system of principles that we can derive similar procedures from instead of just trying to wing it or just have a collection of tricks, a bag of tricks. And effective. Effective means that it improves behavior sufficiently to produce practical results for the participants, right? The improvements in behavior must reach clinical or social significance. The extent to which changes in the target behavior result in noticeable changes. So this means that applied behavior analysis is not only that we have an understanding of behavior, but it's also that it's effective, that it really improves behavior to the extent in which it's not only noticeable from the practitioner, from the analyst, but is also noticeable and it has social significance for all the people involved. So it's very effective. It has to be social significance change. Generality produces behavior changes that last over time, appear in other environments other than the one in which intervention was implemented, or spread to other behaviors, those not directly treated by the intervention. So what they're trying to say here is that the changes that we're produced, the improvement is going to not only be effective, when we are there. Like for example, I've heard this before where a parent can say like, "Oh yeah, he behaves very good when mom is here, but like once mom is not here, and or once he goes outside with other children, he does not do um, what we taught him to do. So behavior analysis does not work." So yeah, what you want to do in applied behavior analysis is that you produce behavior changes that not only last over time, but they are, you want to make sure that you generalize these changes in other environments as well, you know? And you do that again by following the attitudes of science, by uncovering the variables, by teaching in other environments and making sure that you are using general